So let's talk about roaming now. We know what roaming is. Roaming is a method by which client stations move between RF coverage cells in a seamless manner, right? Movement between RF coverage cells in a seamless manner. As simple as that. This is what roaming is, and we want to make sure that roaming happens seamlessly in our network. Honestly, roaming is the most common problem that I have seen in the networks that I've worked on, whether it's in India or it's outside India. I honestly have not seen a network where there hasn't been a roaming problem even once. Okay, and there are many reasons for that. We'll discuss about that also as we go along. Uh, Roaming problems can be caused by poor network designs, of course, and faulty client drivers also. So a poor network design is the biggest cause of roaming, and a faulty client driver. Mostly I've seen in a Wi-Fi network where there are some laptops which are being used, some old laptops, some old scanners, some old devices which whose drivers are not updated. So updating the driver can help. Sometimes the device has gone bad, so you will see some roaming issues happening. Mostly faulty client drivers is not a very major cause of roaming problem. I've not seen that very often, but a poor network design is something which is the biggest cause of the roaming problem in the network, right? And also to keep in mind that clients make a decision. Clients are responsible to make the decision for roaming. It's not the access point. Clients make roaming decisions. Okay, always clients make roaming decisions. So when there are roaming issues going on, we don't need to always fall onto the access point. There are some reasons, some decisions which are made only by the clients. Yeah, even though some vendors do try to control it, do try to basically have involve the access points or the controllers to take that decision, but ultimately it's a client decision, client that initiates the roaming process with a reassociation frame. So a reassociation frame is sent by the client to the target AP to initiate a roaming process that is going to happen, right? Okay. So what all parameters are checked by the clients when they basically do a roam? They check RSSI value, they check noise level, they check the bit error rate, SNR, they check the noise level of the target AP, they check the bit error rate. These are some parameters they look at when they decide that they want to roam, right? So as and when the clients are already connected onto an access point, right, they keep probing, even though they are onto another they are connected to an access point, they keep probing for other access points with better signals. Okay, so they keep making a list of access points which are around them at better signals, so that if needed they can actually go and connect to that access point, right? So as the received signal from the original AP grows weaker, right, to the AP that they are connected to, as the signal grows weaker and a station hears a stronger signal from the other AP, they will check the SNR error rate and the retransmissions also, and then they'll start to roam. They'll start to make a decision about the roaming also. So that's pretty much what happens when a client wants to initiate a roaming process, right? And I'll show you how it looks like. Let's say we have an access point right here, and this is, let's say, a BSS, and there is another BSS, something like this. Okay, I mean, not a BSS, basically it's an access point right here in the middle, and one client, sorry, this is a client here in the middle. Let me quickly correct that. Yeah, okay, so one AP is here, another AP is right here, and there is this client that was earlier here, client number A, and now has and connected to the access point just fine. This access point number 1, and this is access point number 2, Now the client slowly walks to this area and reaches this place where now the signal with this access point becomes, kind of grows really bad and then gets to minus 85 dBm, for example. Okay, this is when it starts to see the access point which is close by and at minus 65 dBm. That is when this client will send a reassociation frame and initiates the roaming process or initiates the roaming procedure. That's how roaming procedure starts. Yeah, there is too much of detail available about roaming which I'm not going to cover in this course, but you can and you should learn more about roaming. If you want to know the fundamentals of technology, then roaming is a very, very important topic that you need to go in detail and understand. All the frames exchanged, how does it really happen, what happens after the roaming is done, how is the data transferred from the old AP to the new AP, all that you need to know to understand the fundamental and the roaming process in detail, right? Anyway, this is the original AP. This is the target AP. Yeah, so that's how roaming really works. Now roaming is more or less a proprietary method. Okay, so it's possible that let's write that down. Proprietary method. So one vendor, it's possible that two laptops of different vendors may roam with at different values. So let's say I have an access point where I have different clients of different vendors connected. One client can start the roaming process if the signal drops to around minus 75 dBm. Another vendor may configure the client card or the Wi-Fi card in the client to start the roaming process if the values or the signal strength goes beyond minus 80 dBm. So it all depends on how the vendor has implemented that, and basically one vendor can have at minus 80 dBm, another vendor, second vendor in the same network can push the client to roam even at minus 75 dBm. So it all depends on how the vendors have implemented that, because it's a proprietary method. They can select their own value, and each vendor's client card is configured with this value, is pre-configured with this value, I should say. So it's known that different laptops of Apple can roam at X value, different laptops of Windows can roam at Y value, depending on what is set in the Wi-Fi card, right? Now that's also something very important and we should know, because in a network where we have in a heterogeneous network where we have multiple different types of clients connected, you can, as a network admin, you will more or less see roaming issues happening, because some clients will roam sooner, the other will not roam that sooner. Some vendors encourage fast roaming, some vendors want their clients to roam quickly, at a lower level. Some vendors want to have a slow roam, they don't want the clients to roam that fast. They want to make sure that the value should really reduce, and then only they should roam. It all depends on the preference of the vendor, right? Now one more thing, there are some measures taken by IEEE also to encourage and to make sure roaming is streamlined, something like .11k, 802.11k, which is kind of like radio resource management, and they also build neighbor reports and understand what APs are next to me, which are providing me with this much signal, and all the parameters which I talked about, and what is the yes, let me scroll up. Yeah, all these parameters along with the retransmissions, all these parameters are checked with all the neighboring APs, and a neighbor report is created, so that an informed decision can be made if the roaming has to really happen at that time. Along with that, there is a .11r fast roaming also, which is implemented by IEEE for secure fast handoffs, to make sure roaming happens quickly and there is no drop in the network and the performance is not degraded, right? So that's these are some measures taken by IEEE to promote that. Now the best way to really ensure a seamless roam, I mean, these are all good things, but the best way in my eyes to make sure there's a seamless roam happening is to have a proper design done. Okay, we underestimate the power of a good design in Wi-Fi. I've seen that with many customers. But a proper Wi-Fi design and a thorough site survey can really ensure that roaming is controlled as much as possible, and clients to roam properly. Usually vendors suggest that there has to be a 15 to 30% RF coverage overlap, right? This is all good. I mean, you can have an overlap of 15 to 30%. That's going to make sure that the roaming is done properly. But in my eyes, there are a few things that need to be taken into consideration. One is the primary coverage. So what it means is, let's say we design a primary coverage to be at minus 67 dBm. Okay, I want the client on the ground at all times to be able to receive minus 67 dBm of coverage RSSI value. This is done using a site survey. Now there has to be a duplicate coverage also, okay, which means I can have the same coverage, the client can have a duplicate coverage of minus 67 dBm from a different AP, in that AP, so that in case my AP fails, I can rely on another coverage to service the client also, right? So that's something which I need to take into consideration, duplicate coverage. Now there is something called, that's pretty much what I want to do to make sure my roaming happens along with the enough overlap that I have of the RF coverage cell. So make sure that this value that I have chosen depends on network to network. If I'm deploying a data network, then yeah, this is good. If I'm deploying a voice network, I would change it to minus 65 dBm, just to keep some buffer also, and make sure there is some I'm keeping into mind some change in the network and the environment also. So yeah, I would want to make sure this happens, and I want to make sure that the access point or the client should be able to hear at least 2 APs at one point in time, so that if roaming needs to happen, it should happen, right? Now if there is not enough coverage overlap, then yes, there will be some roaming issues happening, right? So not enough RF coverage overlap, then roaming issues can happen. And on the flip side, if there is enough coverage overlap, too much coverage overlap, that is also bad. You do not want to have a client. Let's take an example. I have one access point. Let's say I have an access point very close to that, okay, and then there is just too much overlap here. Now my client connected here, or client situated here, is already connected on this particular access point, and even though it is sitting very close to this access point, but has good enough signal from this access point to not start a roam. Okay, that makes sense, because the roaming threshold has to be breached for the client to roam. So there's a possibility that my client might be under a different AP but still connected onto the first AP. That's also a scenario which we don't want to have. So too much coverage overlap is also bad. Too less coverage overlap is also bad, so that the client, if there's not enough duplicate coverage overlap, then the client will disconnect and will not be able to roam seamlessly, and thus you will have disconnections and client connection issues in the network. Another thing that I want to highlight is the latency problem that the client really faces during roaming. Now if I say, let me just write that down, latency issues. How is that happening? Now let's say my client is using 802.1x security protocol, EAP authentication, right? Now the entire process of EAP will take approximately 700 milliseconds to finish. Okay, now if a client is roaming, we expect a reauth to happen, which will again take 700 milliseconds. This is 700 milliseconds will include the 4-way handshake, which is the key cache, the 4 keys that are generated to encrypt and decrypt the unicast and the broadcast traffic. Anyway, yeah, so reauth will take the same amount of time, 700 milliseconds. Now a voice traffic or a voice client cannot take more than 150 milliseconds. Anything more than that, the client will drop, the client will lose the call, the voice call will be dropped. So we have to make sure that the entire roaming process happens within 150 milliseconds for a voice call to sustain and voice call to work properly, right? That is something which can become a challenge. Now there are different procedures like FSR, fast secure roaming, which has different key caching mechanisms, which are again deployed differently by different vendors. Now there are multiple types of key caching mechanisms which can be used to bring down the reauth, and because the keys are already cached, and the entire process of roaming, even for a voice client, can be less than around 80 milliseconds, sometimes 100 depending on the latency in the network. So the entire roaming can happen in this much time, which means the voice call will sustain, things are fine, the client should be able to roam properly without any hassle, right? Other issues which can be responsible for a roaming problem is a change in the environment, right? Change in the WLAN environment. This is very common because let's say a network was deployed 6-7 years back. It's very common and obvious that there will be some changes in the network. There will be some APs that will go bad, and the network admin might just forget to replace those APs because those APs are not very often used. Some seating arrangements will change, some new rooms will come up in the office. So those kind of things will always happen, which will cause which will cause a lot of problems for the roaming to be sustained on the ground. There is a possibility that a newly construction building might come up, and then that may also cause roaming issues. Let's say some metal doors are built around, some glass doors are built, some glass rooms are built, which will also cause a lot of interference, a lot of multipath, which also will degrade the network performance and cause roaming issues, right? So it's a very good idea. So I mean, according to me, it's a very good idea to periodically have a site survey done, periodically check for coverage, periodically check for coverage, and do that using a site survey tool. I don't know, Ekahu or Air Magnet or whatever suits you, but do it periodically, and just make sure if there's any change in the coverage patterns or of the access points, or some access points might have gone bad, which you may not even know. Something, all those things will come to light once you do that. So it's always good to do these things proactively and make sure that your roaming is done the right way on the ground, because roaming issues are the most common issues that I have seen in the network, and they are the most probably the most difficult ones to troubleshoot also, because once you hit those issues, there's a coverage hole, there's not enough overlap happening, and the easy way is to deploy an AP. Of course, go and deploy an AP when you see a coverage hole, but that may not always be the right solution. So you have to assess everything, keep all the parameters in your mind, and do a thorough analysis, and then take some reactive measures, or you can take these proactive measures to ensure that the roaming on the ground is always smooth. There'll always be issues, of course, but yeah, just do a periodic check for coverage, do a site survey done. Let me just write down here, it's a site survey that I'm asking you guys to do periodically, or have a vendor that does a proactive site survey through a third radio of an access point. There are some vendors who provide access points which will do the site survey automatically from the third radio of an AP. You may not need to send a guy on site to do a survey that in that scenario. So yeah, this is something about roaming, but I would again say roaming is a very, very vast, detailed topic, and you need to know a lot more of it. So if you've not yet done, go through a CWNA textbook or watch the other course that I have. In that, I have explained roaming in detail, which will really benefit you. Thank you.